Good morning, students. I am going to continue yesterday topic, and we started the dual nature of radiation and matter. And in that little bit, we discussed about the threshold frequency, threshold wavelength, work function. And now I am going to start the photoelectric effect. What is photoelectric effect, right? And what is the experimental study of photoelectric effect? That I am going to explain. Today's topic is very important for the board exam and even for the competitive exams also. Right? Listen very carefully. Photoelectric effect. This is my topic. Photoelectric effect. What is photoelectric effect? You know very well about the photoelectric effect. Previously also you know. Right? What is photoelectric effect? First I will write the definition. And before going to definition, once you can give the confirmation whether the audio and video is it clear or not. Writing and this one voice, is it clear? Can I continue? Anyone can test it? Test the message. Photoelectric effect definition is: photo means light, electric means electrons emits. When light falls on a metal, the electrons emit from the metal. That phenomena is called as photoelectric effect. It is very simple. When light falls on a metal surface, on through the metal surface, electrons releases. This phenomena is called as photoelectric effect due to the photons, due to the light. If electrons emits, that phenomena is called as the photoelectric effect. Right? Now I will give the definition. The phenomenon of emission of electrons, phenomenon of emission of electrons from a metal surface, from a metal surface, when it is when it is illuminated by the light of suitable frequency. Suitable frequency. That the frequency of incident radiation should be greater than threshold frequency, then only electrons will emit. That is called as photoelectric effect. This is the definition of the photoelectric effect. It's a definition explanation I will give. It was very simple to understand. Okay. What is the definition? Once see here. The phenomenon of emission of electrons from a metal surface. From a metal surface, electrons emits. When it is illuminated by the light, that means if the metal is focused to the light, okay, and if the light falls on the metal surface, then electrons emits from the metal surface. That phenomena is called as the photoelectric effect. Let us see here. This is a metal surface, right? And here the light is incidenting. For example, this is a light that is incidenting on the metal surface, and you see here this is the light. The light should have certain frequency to emit the electrons. This metal has so many electrons like this minus one are the electrons, and when any electrons gains the light energy, that electron will be liberated from the metal surface, right? This electron will comes outward from the metal surface. That electron emission, okay, from a metal surface when it is illuminated by the light is called as photoelectric effect. Okay, and this will not happens for every light. It will depends upon the nature of, it will depends upon the light, and it will depends upon the nature of metal to metal. Okay, it will be changes. Previously we discussed, that is, if the frequency of incident radiation is greater than threshold frequency, then what happens? Threshold frequency is the minimum frequency to emit the electrons. Then electron emission occurs. That means photoelectric effect occurs, right? Okay, photoelectric effect means what? Due to the photons, due to the light, electron emission should be occurs. Right? Electron emission is occurred means that is a photoelectric effect occurred. Photoelectric effect is nothing but electron emission. Right? Now here, if frequency of incident radiation, if it is greater than threshold frequency, then photoelectric effect occurs. Right? Very good. And if the frequency of incident radiation is not sufficient, right? It is less than the threshold frequency. Threshold frequency is what? It is the minimum frequency, right? Minimum frequency to minimum frequency to emit the electrons. Just like this. For example, uh, uh, out of 70 marks exam will be there for the physics exam. Then you have to get the 23 marks. 23 is the threshold frequency, right? Threshold frequency mass. And if you got 23 and mass and above, then you will be pass. And if you will get the less than 23 mass, then you will be fail. That means this 23 marks is the cutoff, right? If you will get less than the 23, then you cannot pass in the exam. And if you will get 23 and above, then you will be pass. Similarly, if any light has the frequency that is greater than threshold frequency nu naught, then that light will emit the electrons from the metal surface. If any light has a frequency that is less than the threshold frequency, that is nu naught, then that light cannot emit the electrons, means photoelectric effect not occurs. Photoelectric effect not occurs. You have to enjoy with the subject because it does not contains the derivations and only concept. Okay, photoelectric effect not occurs. The topic also very interesting and very easy also. You write in the chat box if you have the doubts. Okay. Next topic is, after the photoelectric effect, I am going to explain the important topic. Okay, that is the experimental study of photoelectric effect. Experimental study. Experimentally, practically, then on what factors the photoelectric effect depends, and that all things we are going to discuss. You listen very carefully. That is a very important topic. Yes, the topic is Lenard. Lenard experimental study of photoelectric effect. Photoelectric effect. Okay, this is our topic. Lenard is a scientist name. He find out this experimentally the photoelectric effect. Okay, and he explained on what factors the photoelectric effect will be depends. Okay, that all things. Then you listen very carefully, and this is very easy and very interesting. Okay, and for that I have to draw one figure. Okay, and this is, otherwise I will directly upload the figure. No, it's not possible. No, that file is not appearing. Okay, leave it. I will draw. And now Lenard experimental study. That further purpose, let us consider this is a sketch we will take. Okay, this is a tube, and these sketches are not appearing. 1 minute, I will close from where I have to get these all sketches. Listen it here. 1 minute gap is there. Oh, due to some problem, technical problem, the sketches are not appearing, and then I closed the board and again I am opening. 1 minute gap is there. Yes, is it okay now? Very good. Now I'm going to continue. And this is a evacuated glass tube. Okay, this is a glass tube. This is evacuated glass tube. Evacuated means evacuated means air is removed. Evacuated glass tube. And now for this we are connecting this one to throw rheostat. Okay, this is a rheostat. Through rheostat, this end is connected to micrometer. Okay, this is micrometer. It can measure the current, and this end is both ends are connected to battery. This is the battery. This is a battery. Right. This is the diagram. You see here very carefully, and this is the diagram. It is useful to study the experimentally the photoelectric effect. In this, what are the various parts? Okay, and here we can also use one a plug key. Okay, this is a plug key. Right. This is a battery. It has some potential. Here, some potential difference is there between these 2 points. Then this rheostat, why we are using it here? The rheostat we are using to change the potential difference. This is the cathode that we are connecting to the negative terminal of the battery. Cathode is connected to negative terminal, and this is said to be anode. Okay, and this is the cathode, and this is the anode. Anode is also called as collector. Anode is also called as collector, and cathode is also called as emitter. Okay, emitter. And this is the quartz glass window. This is the quartz glass window. Okay, right. Now this is the battery. From the battery, current will be supplies, and then this is the cathode. It can emit the electrons. Now, how much current shows by the micrometer? Okay, what is this? You see, the blue one is the evacuated glass tube, which is a tube, and one end is connected to the negative terminal, and other end is connected to the positive terminal, right, of the battery. And when we close the plug key, then whether the current flows in the circuit or not, can anyone answer? Can anyone answer how much current flows in the circuit? Yes, it is the zero. Okay, zero current flows. Why zero current? Here there is a gap between the cathode and anode. You see the cursor. This is cathode and this is anode. They are the two metal plates. Okay, these are the two metal plates, and now between them gap is there. This is evacuated, even air also not there. There is no direct connection. That's why it is an open circuit. In open circuit, current does not flows. But what we are doing it here, we are making some light to incident it here. Okay, we are making the light to incident through the quartz bulb. Then the light is incident on the light incident on the cathode. Okay, on the cathode, through the light will be incident like this. The light rays are incidenting. The light rays are incidenting it here like this. Then the light rays are incident on the cathode. Cathode we can take as the photosensitive metal. Then electrons emits from the cathode. That electrons emits due to the photoelectric effect, and they will travel towards the anode, and then the circuit will become closed and the current flows and the micrometer shows the reading. That means when light falls on the metal, when the light falls through the quartz bulb. Okay, this is a quartz glass window through that the light will be falls, and that due to when light falls on the metal plate, this is a cathode is a metal, and when the light falls on the metal plate, then what happens due to the photoelectric effect, electrons will emit, and these electrons passes through this evacuated glass tube, and then some current will be flows in the circuit. Now we are going to study on what factors this current will generates. Here the emitted electrons are called as photoelectrons. Okay, I'm going to continue the topic. Is it clear now till now? And any problem is there, you can write. Dev Mathav, Sara, is there any problem? Is it clear, voice and audio video? This is experimental study of photoelectric effect. Experimentally, photoelectric effect phenomena is studied. Now you see some points, few points I will explain regarding this. What happening at here? When light falls through the glass window on the cathode, okay, then the electrons emit from the cathode, okay, and that electrons are called as photoelectrons because due to the light they are emitting. Okay, electrons emitted from metal surface. Electrons emitted from metal surface. Okay, that is the just like here cathode. Electrons emitted from the metal surface from the cathode due to photoelectric effect. Due to photoelectric effect, due to light, the electrons are emitted. That electrons are called as electrons emitted from metal surface due to photoelectric effect are called as photoelectrons. Okay, are called as photoelectrons. Due to the light, the electrons are emitted. That's why they are called as the photoelectrons. And the next one more point I will give. The current generated here, the current is passing in the circuit due to the photoelectrons. The current generated due to photoelectrons. Okay, the current generated due to photoelectrons is called as photocurrent. Due to the photoelectrons, the current is producing it here. Due to the photoelectric effect, electrons are generating this minus one, minus one, minus one. You see figure in the this minus are the electrons. These electrons are generated due to the photoelectric effect. The electrons are called as photoelectrons, and the current generated due to photoelectrons is called as photocurrent. Photocurrent. Okay, right. Now, I'm going to explain a few points. Okay, that is on photocurrent on what factors it will depends. First one, I am going to explain effect of very important points. I am going to start effect of intensity, effect of intensity of light, effect of intensity of light on photocurrent, on photocurrent. This is my topic. What is the effect of intensity of light on photocurrent? If we increase the intensity of light, then what happens to the photocurrent? Okay, photocurrent means what? Generally, the current generated due to photoelectrons is called as a photocurrent. If we increase the intensity, if we increase the intensity, that what happens? The light will be intensity is increased. Generally, actually, intensity means what? Intensity is nothing but energy by time into area. We discussed in the wave optics chapter, right? This is the intensity formula. Energy means what? This light travel in the form of photons. Then the photon energy is what? Photon energy is nh. One photon energy is h nu. Light travel in the form of particles according to quantum theory. Each particle is called as quanta. Then yeah, each quanta has energy h nu. Okay. Then n quantas are there. N photons are there. Then nh nu is the energy by time into area. Then n is the number of photons. If intensity proportional to number of photons, when number of photons increases, then photons also intensity also increases, right? Then what happens at here? When the intensity is increased, when the intensity of light is increased, intensity of light is increased, generally in the morning session, in the morning, okay, intensity of sunlight is less, and in the afternoon intensity of sunlight is more. Like this intensity will be varies. When intensity increases, the energy of light increases. When the energy of light increases, the number of emitted electrons per second increases. When number of emitted electrons will be increases, then automatically the current also increases, because the current formula we know is current formula is charge by time. But the charge is we know that Ne by T. Okay, that means N is the number of electrons. Number of electrons. Is it right? But what happening at here? When intensity increases, okay, this is the intensity of light that is incidenting on the cathode increases. Then what happens? Number of emitted electrons also increases. You see the figure. Number of emitted electrons also increases. When number of emitted electrons increases, automatically the current increases, because when intensity increases, N increases, I increases. That means they observed that the photocurrent linearly increases with increase in intensity. Okay, this is the effect of intensity on photocurrent. Then next point I am going to explain, that is the effect of anode potential on the photocurrent. What is the effect of anode potential? Okay, before that I am going to do one thing, that I need this diagram actually. Next remaining continuation I will explain based on the diagram only. Okay, again I will draw. It is better to draw next. Okay, I am going to continue. I am going to erase. You take the screenshot. No, it is not erasing. I will erase manually. Look at here very carefully, and the points that I am going to explain now that are very important. I will draw some graphs, and from the graphs you will get in the exam. You listen very carefully. Right. What I am explaining previously, just what is the effect of intensity on photocurrent? Right. Now that is the intensity of light. When the intensity of light changes, then the photocurrent also increases. Okay. The photocurrent linearly linearly changes with the change in change in intensity of incident light. Intensity of incident light. If the intensity increases, then photocurrent also increases. That means we write photocurrent is directly proportional to intensity of light. Okay, small I is the photocurrent and capital I is the intensity of light. Intensity of light. That means when intensity increases, photocurrent increases. When intensity decreases, photocurrent also decreases. How intensity changes, like that photocurrent will be changes. Let us draw the one graph, that is photocurrent versus intensity graph. Okay, we are taking the photocurrent intensity of light on x-axis. Okay, intensity of light on x-axis and the photocurrent on y-axis. Photocurrent on y-axis. Okay, intensity is capital I and the photocurrent is a small I. Then how you will get the graph? When there is no intensity of light, there is no current. When there is no intensity of light, if I is zero, no intensity of light means if light not falls on the cathode, then electrons not emits. When electron not emits, then current does not flows. That means 0 comma 0 it will starts. And when the intensity increases, then photocurrent also increases linearly. You will get a straight line that is passing through the origin. This is the graph between the photocurrent and intensity of light. This is the how photocurrent changes with the increase in intensity. And the next one, effect of second point I am going to explain. The second point is that how anode potential affect the photocurrent. Okay, the second point is that, Effect of anode potential on the photocurrent. This is the second point. First point I said that effect of intensity on photocurrent. Next one I am telling that effect of anode potential. Effect of anode potential. Of anode potential on photocurrent. On photocurrent. This is I am going to explain. Okay. You listen very carefully. If you have the doubt, immediately you can ask. You can write in the chat box. Till now, is it clear? You can write in the chat box. Quartz glass. Okay, one member is asking the Aditi, right? Quartz glass use. It is the transparent glass. Okay, through that light can passes. Right. Uh, that is only use. Okay. Effect of anode on photocurrent. You see here, we are taking a evacuated glass tube, right? This is a glass tube. In this, one cathode we are taking and one anode we are taking. This is the cathode. Okay, this is the anode. Okay, and now through this, the light falls at here. The light is incidenting through the glass window. Okay, and this is the cathode, and this is the anode. What I am doing it here, this cathode is the negative. It is connected to negative actually, and it is connected to positive. And then when the positive potential of cathode is increases, when the positive potential of anode is increases, actually here electrons are released at here. Electrons will travel like this, right? If anode potential increases, if the positive potential of anode increases, then what happens? If positive potential of anode increases by keeping the frequency of incident radiation and frequency is constant, and photosensitive metal also nature also constant same, and they are not changing for a given photosensitive material. Okay, for a given photosensitive material, where we are using this photosensitive material, photosensitive material is used as cathode, right? Through that light will emits. When light falls on the photosensitive metal, then electrons will be emits, right? Then for a given photosensitive metal, okay, uh, and frequency of incident radiation, frequency of incident radiation. If anode, if the positive potential, first point I am going to give. If positive potential of anode, if positive potential of anode, you know what is right side one is the anode. If positive potential of anode, if positive potential of anode increases, then what happens? Increases, then photocurrent also increases. Photocurrent also increases. Then photocurrent also increases and become maximum. Why it increases maximum? Increases and it becomes maximum. And it becomes maximum. Then after it is remains constant. Why the current increased at here? I will explain. Look at here. See the diagram. You see the diagram kindly. Okay. The cursor moving. You can see the light is falling at here. The light is falling, and when light falls at here, the electrons are empty. But it's some of the electrons. Okay, these are the all electrons. and some of the electrons may not have the more kinetic energy to reach the anode and to fall on the anode. But what happens in the middle, they will drop. And if the positive potential is increases, positive potential on the anode increases, then what happens, the attraction power is increases, this positive anode attracts the negative. That's why the electrons goes with large speed, and electron speed increases, and the number of electrons reaching the anode also increases. Why that is increasing? Because this positive anode attracts the negative electrons. That's why when you will increase the positive potential on the anode, the positive charge will increases. That's why attraction force on the electrons increases. That's why more electrons reach the anode. More electrons reach the anode means more current will be produced. Like that, the current increases with increase in positive potential of anode. But after some time, after certain positive potential, what happens? How many electrons are releasing per second? That many electrons are received by the anode. Then if the positive potential further increases, then there is no further electrons to attract the electrons and to reach the anode, because how many electrons are releasing it here, that many electrons are attracted already, that many electrons are receiving the anode. How many electrons releasing per second, that many electrons are received per second by the anode. How many electrons released from the cathode per second, that many electrons are received by the anode per second. ओके, कितना इलेक्ट्रॉन्स इधर से इमिट हो रहा है, उतना इलेक्ट्रॉन्स इधर रिलीज हो रहा है। फर्दर आप इधर पोटेंशियल बढ़ते तो कोई यूज नहीं है, इधर इलेक्ट्रॉन्स का काउंट इंक्रीज नहीं हो रहा है। दैट मीन्स here after certain potential, then if you will increase the potential, no use, then the photocurrent does not increases, right? Because there is no increase in number of electrons. The maximum value of current, here the current starting, what happens, starting when you will increase the positive potential, then more attraction will be there, more electrons will reaches. But after certain potential, what happens, certain positive potential, how many electrons are releasing, that many electrons are attracting. That's why there is no further electrons to attract. Okay, that's why what happens, the current does not increases. Okay, the maximum value of, the maximum constant value of current is called as saturation current. We will come to the saturation. Is called as saturation current. Saturation current means maximum current. Okay. Next, I will rub the left side. You take the screenshot. Okay, next continuation. Listen very carefully. Right. This is when you will increase the positive potential. What happened? We discussed. If you increase the negative potential, what happens? If negative potential, if negative potential, if negative potential of anode, for example, I am giving the negative potential for the anode. For the anode, I am giving the negative. Okay, this is the, in the figure, anode is generally positive, but especially I am giving the negative. If negative potential of anode increases, then what happens? Increases, then photocurrent decreases. Photocurrent decreases. Photocurrent decreases and it becomes zero, and it becomes 0. What becomes 0? Photocurrent becomes 0 at a negative potential. Okay, that negative potential is called as stopping potential. Why the photocurrent is decreasing it here? Listen very carefully. See the diagram. See the diagram. What I am doing it here. Okay, right. No need to draw the further diagrams. I will explain the same diagram. Okay. You see here the diagram. For this is an anode. You see the right side diagram. You see this anode A. Okay. For this, if you apply the negative, then what happens? Electrons are negative charged. They want to reach the anode. If you apply this negative, what happens? These electrons are repelled by this negative anode. Anode is generally positive, but specially I am giving negative potential. Then what happens? If negative potential, if we will use this is a negative charge, it becomes these electrons, released electrons are try to go anode, then these electrons are negative charged. This anode also negative charged right here. Especially I am giving negative charge for the anode because negative potential I am giving. This negative repels the negative. That's why the movement of the electrons will be stopped. Then I am increasing the negative. I am increasing the negative. At the moment, the repulsion force is increases because the electrons are negative charged. The anode is negative. Now, the repulsion force is increased. At a particular negative potential, what happens? All the electrons are repelled. Even one electron also not allowed to reach the anode. At that moment, the number of electrons reaching the anode becomes zero. That's why the current become zero. That means when you will increase the negative potential of anode, the number of electrons reaching the anode decreases because of repulsion force. Right? When the number of electrons reaching the anode decreases, at that moment photocurrent decreases. Then at a particular high negative potential, total electrons are repelled by the negative anode. That's why even one electron not reaches the anode. Electrons are not reaching the anode means current become zero. The negative potential at which the current becomes zero, that is called as the stopping potential. Right? Students, is it interesting? Write in the comment box. Right. Let us continue. Stopping potential. What is stopping potential? What is stopping potential? Okay, see here, very carefully you have to hear. Something is wrong at here, something is going on. Listen very carefully. I'm going to continue. The minimum value of negative potential. Okay, the minimum value of negative potential. The minimum value of negative potential. The minimum value of negative potential at which photocurrent becomes zero. At which photocurrent photocurrent becomes zero is called as is called as stopping potential. What it is called? Stopping potential. This definition is very important. What happening it here? What is stopping potential? When you will increase the negative potential, 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 right? You increase the negative potential at here, at a particular negative potential in the figure you see, the cursor you see. When you will increase the negative potential at a particular negative potential, total electrons are repelled. Even one electron not reaches the anode. That means certain negative potential, the negative potential at which total electrons are repelled, the photocurrent becomes zero because even one electron not reach the anode. Right? That potential is called as the stopping potential, and it is denoted with V naught. It is denoted. It is denoted with V suffix 0. It is called as stopping potential. Stopping potential. This definition is very important. Okay. And next, here the battery is doing some work at here. Okay. The work done by the battery in this case. Work done by battery to stop the electrons. Work done by battery is equal to change in kinetic energy. Their kinetic, due to the repulsion force, their kinetic energy becomes zero. Work done by the battery is the charge into potential. You know potential equal V equal W by Q. Yes, you know V equal W by Q, from the W equal to VQ. Potential into charge. The potential to stop the electrons is V naught and the charge is minus E. And the change in kinetic energy is the final kinetic energy minus initial kinetic energy. But initially the electrons have the maximum kinetic energy, but the final kinetic energy is zero. Then initial kinetic energy is Ke max. Okay, then maximum kinetic energy of electrons formula will become, what happens from this? I'm going to erase the right side. Now you see very carefully, and I'm going to continue from this. Ke max is the maximum kinetic energy of electrons. It will become ev naught. This is the formula for the maximum kinetic energy of electrons. Okay, Ke max is the maximum kinetic energy of electrons. Maximum kinetic energy of electrons. Maximum kinetic energy of electrons. Okay, E is the charge of electron. E is the charge of electron. And V naught is what? Stopping potential. Stopping potential. Okay, right. Let us draw the graph between the photocurrent versus anode potential. Okay, photocurrent versus anode potential graph. Photocurrent versus anode potential. We draw the graph, then how would you will get? Whatever that we discussed in the theory, based on that, now we draw the graph. It was very simple. Okay, you listen very carefully. This graph is very important for the exam. In the board exam, they will ask to draw the graph only. This is the anode potential. Now, this is the anode potential. Anode potential that we are taking the positive, right? And this side negative potential we are giving, retarding potential. Retarding potential, we say that. On x-axis, we are taking the potential. Okay, right. On y-axis, I am taking photocurrent. Photocurrent I am taking. Photocurrent. Now, how you will get the graph? This is an origin. And graph I will draw now. You listen very carefully. First, when we will increase the photocurrent, when we will increase the positive potential from 0 to right side, origin right side, anode positive potential. This side positive will be there, this side left side negative will be there. When we will increase the positive potential, then what happens? Photocurrent also increasing, and become maximum, right? And if we increase the negative potential, what happens? If we increase the negative potential, then photocurrent decreases, and becomes zero at a particular potential. That potential is called as stopping potential. That potential is called as a stopping potential. And now this is at intensity I1. Then, if we in this, the saturation current is what? Maximum current is what? This is the saturation current. Okay, this is the maximum current. I max. Okay, I1 max. This is saturation current. And now further I am taking some other intensity which is greater than this. Okay, at I2 intensity I want to draw. Okay, at I2 intensity if you will draw the graph you will get like this. This is at I2 intensity. If you write at I3 intensity, okay, leave it and 2 is enough. Okay, what happened? The diagram is damaging. Okay, students, 1 hour is completed. It's taking much time. Even I will complete more some time I will take because the topic is not completing. It is taking much time with writing and explaining. Sometimes the board is also giving the struggle for me. Don't worry, I will try in all the aspects. Good. This is the diagram. V naught is the stopping potential. Saturation current in the second case is I2. And now in these two cases, some factor we will keep it constant. That is the frequency. The frequency of incident radiation is constant. Frequency is constant. Okay, right. This is the graph between the photocurrent versus and photocurrent versus anode potential. If anode potential increases, then what happens? Okay, you see, I will explain once again. This is for certain intensity I1. Okay, here the in the figure I2 is greater than I1. I2 is greater than I1. That will implies small I2 maximum is also greater than small I1 maximum. What it indicates? You see very carefully this diagram and everything. I will explain graph once again. This is the positive potential of the anode. origin right side is the positive potential, right? Origin right side is the positive potential. If you will increase the positive potential, you see the blue line, right? Current also increasing, increasing, increasing. Later we get a straight line. Means current become maximum and constant. That maximum current is called the saturation current. This I1 is the saturation current. And if you will increase the negative potential, then the photocurrent is decreasing. The graph goes down, down, backward like this. At a particular potential, the photocurrent become zero. That potential is called as the stopping potential. This V naught is called as the stopping potential. That is a minus V naught. And we drawn this graph for the another intensity. There is we are taking this at I2. I2 is the some other intensity which is greater than this. When the intensity is increased, automatically saturation current is increased at here. Maximum current is increased, but the graph is exactly same. Okay. Then what we can write from this graph? What we can write from this graph? Okay, students, do you have the patience to listen more 15 minutes? Respond. I'm going to write up the left side. A response. Do you have the interest to listen more 15 minutes? Right. I'm going to continue. That is, from this graph, we write some result. Okay, some result we can write. What we write the result from the graph and importance from the graph. We write something. Few points I will write. First point is that from the figure, right? We write one thing. There is a saturation current. Saturation current depends upon the intensity of light. Right? Saturation current. Saturation current means what? Maximum current. Saturation current depends upon saturation current depends upon intensity of light. Intensity of incident light. When the saturation current increases, intensity of light increases, saturation current also increases. Saturation current means maximum current. This is also directly proportional to intensity, right? Saturation current depends upon the intensity of incident light. This is the first observation. When the intensity increases, then the saturation current also, maximum current also increases. You see this here. That is when the intensity increases, then the Imax also increased. This is the first point. And one more point is that when the intensity decreases, then the saturation current also decreases. The next one is second point what we can write from the figure. Second point we write is like this. Stopping potential. Stopping potential what happens? The stopping potential you see. Stopping potential. Stopping potential is V naught is the stopping potential. For I1 intensity stopping potential is V naught only figure you see. For I2 also stopping potential is V naught. the two intensities, two graphs will come and meet at one point only. That means stopping potential does not depends upon the intensity. Intensity changed from I1 to I2. But the stopping potential does not change. The two are meeting at one point only. That means we can write the stopping potential is independent of independent of intensity of incident radiation. Intensity of incident radiation. Okay, these are observations, 2 points from the graph. This is about the effect of anode potential on photocurrent. 2 points we discussed. The first one is the effect of intensity on photocurrent. Second one is the effect of anode potential on photocurrent. Next, third point is the effect of frequency on photocurrent. That is we have to discuss. Thank you to Shushmita and Punit for giving me a chance for the more 15 minutes, because this is very important. It's a continuation, okay, of the more 15 minutes required to close this topic. Okay, thank you, thanks a lot, and then I am going to continue. I'm going to erase this total. Eraser giving a much problem for me. I don't know what happened. It is not erased. Let us continue. Oh, shit. Let us start. The next one is the third point. Third is the last one. Okay, the last topic related to this. I am going to explain the third point. First one is the effect of intensity on photocurrent we discussed. Next one is the effect of anode potential on photocurrent we discussed. Next one is the effect of frequency. Effect of frequency of incident radiation on photocurrent. Effect of frequency of light on on stopping potential and photocurrent. On stopping potential and photocurrent photocurrent. This is my topic. Okay, continuation. And this is the last one. And if we discuss, we will close this. Oh, okay, right. You listen very carefully, and that I'm going to draw the graph related to this, and I will take two graphs I have to draw. One is by taking this is figure A, what it is showing, and in this you see this is origin, And now we are drawing the graph between the anode potential anode potential versus photocurrent. Previously also we drawn the same graph, right? But in that we are not we are keeping the frequency constant, but in this frequency we are varying. Okay, how you will get the graph? In this graph we are keeping the intensity constant. We are keeping the intensity constant. In this graph we are keeping the intensity as constant. And then what happens it here? We are varying the frequency. This is for the new one frequency. This is for the new two frequency, and this is for the new three frequency. Frequency we are varying, but the potential is intensity is constant in this case. Okay, and what happening it here? From the figure, we will. This is figure A. We will note, and then figure B. Experimentally, we observed these figures. Okay, with the experiment, and in the second figure, we are taking the frequency on y-axis, frequency on x-axis, and stopping potential on y-axis. Frequency on x-axis and the stopping potential on y-axis. That is V naught. And here we have to draw. This is the figure B graph. Figure B. Okay, just within 10 minutes it will close. Don't worry, and you keep the patience. And these graphs are important. In exam, they will ask the graphs only directly. They will draw the graphs. That's all. They will ask to draw the graph. This is for the metal 1. This is for the metal 2. This is the graph. Different metals. This is nu naught. This is nu naught dash. Right. And now we will discuss these graphs. Just we have to give the some result of these graphs, and then with that this will be closed. Today's lecture will be closed. What is the result of these graphs? See the first one. Okay, I am going to give the result of these graphs. What these graphs will says, and this is experimentally by taking the photocurrent and anode potential. In this, what we are doing it here, we are doing that. We are varying the frequency. Firstly, you see this first figure A. In this, we are taking the new one frequency. At new one frequency, we are giving the anode potential, we are increasing, and then the photocurrent also increasing and become maximum. And we are decreasing, we are applying the negative potential this side. When you apply the negative potential, photocurrent is decreasing, and at a particular potential, that is the V01. And at that potential, what happened at here? Oh, photocurrent becomes 0. And for the other frequency, if you will draw, the saturation current does not change. This is the maximum current. The maximum current for all the frequencies it is same. You see, this is the maximum current. This higher line is the same for all frequencies. Nu 1, nu 2, nu 3. Okay, that means from the figure A we write like this. From figure A, we write one thing. That is the saturation current. Saturation current is the photocurrent, right? It is saturation current is independent of saturation current is independent saturation current is independent of frequency of incident radiation, whatever it may be the frequency of incident radiation. Okay, whatever it may be the frequency of incident radiation, saturation current is same. You see, For the nu1 frequency graph, this is the saturation. For nu2 also frequency, this is the saturation. Nu3 also saturation. Imax is the same for the all frequencies. The saturation current is independent of frequency of incident light. When you change the frequency, then saturation current does not changes. But the saturation current depends upon the intensity, not on the frequency. Okay, right. This is the first point. And the next one is the when you will see the stopping potential from the graph we write here, we note here one thing that in this graph nu3 is greater than nu2 is greater than nu1, then v3 greater than v2 greater than v1. When we will increase the frequency, then the stopping potential also increase. You see this even figure b also you see. Okay, from figure b also we write the same thing. That is, there is a, for the metal 1 you see metal 1, when you will go to right side, what happens? Frequency increases, then the stopping potential also increased at here, right? That means now from figure A and B, from figure A and B, we write one thing. That is, actually from the figure A, we write nu3 greater than nu2 greater than nu1. We are taking this one like that. But on the graph, from that we got v03 greater than v02 greater than v01. That means here the stop when the frequency increases from nu1 to nu2, nu2 to nu3, automatically stopping potential also increased. Okay, frequency increased from nu1 to nu2, nu3 greater than nu1. Then stopping potential v3 greater than v1. Means when nu increases, okay, when nu increases, then stopping potential also increases, right? Stopping potential also increases. That means we write here one thing, that the stopping potential linearly changes. Stopping potential linearly changes with the change in frequency of incident light. Frequency of incident light. Okay, stopping potential depends upon the frequency. Stopping potential depends upon the frequency. Stopping potential linearly changes with the change in frequency of incident light. Now, when stopping potential changes, then kinetic energy also, maximum kinetic energy also changes, because actually stopping potential, maximum kinetic energy of electrons, maximum kinetic energy of electrons, K max, third point from the figure A only. Okay, from figure A only we write, or figure B, anything we can write. That is maximum kinetic energy. Actually, maximum kinetic energy formula, what you got, you know? The maximum kinetic energy formula is EV naught. Previously we discussed. Kinetic energy depends upon the stopping potential. Stopping potential depends upon the frequency. That means maximum kinetic energy also depends upon the frequency. There is a maximum kinetic energy of electrons. Okay, students, now I think it is clear for you, and now I am going to give the last point. The fourth point I am going to explain. The fourth point from the figure is that from figure B, from figure B, at a particular negative potential, right? From figure B, stopping potential. From figure B, stopping potential. Stopping potential decreases with decrease in frequency. With the decrease in frequency at a particular frequency, it will become at a particular frequency. Stopping potential become stopping potential becomes zero. This is called as threshold frequency. This is called as threshold frequency. आज रब करते तो कल रब हो रहा है और this is not responding properly. I don't want to skip because it is the last topic. I cannot make one more lecture for this. Oh, kindly you can adjust and you read the textbook. And very interesting topic actually. It is damaged due to the my pen tab. You see the figure here. Threshold frequency or the cutoff frequency we said. From figure B, you see the figure B. When you will go left side, right? Frequency decreases. Then the graph is also going down. This is going like this. That when you will go to left side, this side, frequency decreases. Then the graph is going down. That means stopping potential also decreases. Okay, when you will decrease the frequency, stopping potential also decreases. Then at a particular frequency, this is nu naught, the stopping potential become zero, right? That potential is that frequency. The frequency corresponding to the stopping potential becomes zero. That is called as the threshold frequency or the cutoff frequency. This threshold or cutoff frequency depends upon threshold or cutoff frequency depends upon nature of material. Nature of material. Okay, if you read the book, if you have doubts, then we can clarify later. Okay, thank you for watching my lecture. Thank you to all.